Today's topic is dispersion of light. Many of you must have seen, if you take a prism and if you put an incident beam here, when it comes out, it is not a single color. You got various colors coming out of it, and the top one being red. Then you have yellow. Then you have at the bottom violet. You get all the colors, 7 colors of the rainbow here. Why does it happen? This phenomena of splitting up of an incident ray of white light into its constituents is called dispersion. Now, there are a few terms. Let's see what they are. One is dispersive power of material. Now, you might be wondering what is dispersion. Dispersion is this angle. For example, this will be for red. This will be for violet. So what is dispersive power of the material? This is angular dispersion divided by average dispersion. If I elaborate here, let us say you have right on top red, then you have yellow, at the bottom you have violet. This is the part of the prism. Now the angular dispersion will be this one, total dispersion, or rather I would say the band of dispersion from minimum value to maximum value. This. An average dispersion would be, in actual, the red is dispersed by this angle, yellow has actually dispersed by this much angle, and violet has actually dispersed by this much angle. So what we do is we divide this difference over average of all the values of dispersion. That is dispersive power of the material. This can also be defined as maximum dispersion minus minimum dispersion divided by average dispersion. When we say maximum to minimum, we are talking about this difference. We are not talking about the actual value, but the difference. So what we have done is, from the maximum, this value, we have subtracted, or rather this is the minimum dispersion, and this angle is maximum dispersion. So you can take this way or this way, doesn't matter, it amounts to the same thing. So if we write in terms of colors, this will be what? Because the violet disperses the most, it comes at the bottom, and red Dispersion of red is minimum. This is dispersion of red. So we can write this as dispersion of violet light minus dispersion of red divided by dispersion of yellow light. Why have we taken yellow? Because yellow is is the mean of this whole spectra. Yellow falls somewhere between maximum and minimum, and so we can take it as an average. It represents as an average dispersion. Okay. For symmetric incident ray in prism, mu is equal to sine this formula we have already seen earlier. What is this? This is the angle of minimum deviation. In a prism, what happens is when we send an incident ray, it refracts once and it refracts again. So if there was no media, it would have gone like this. But because of double bending, it goes like this. So ultimately it has bent by this much amount. So this is called angle of deviation delta. And if we adjust, this is our normal, this is our angle I. If we adjust I in such a way that delta becomes minimum, this angle of incidence is called, at that time, the incident ray is symmetric. Why it is symmetric? Because whether you shoot the incident ray from here or you shoot it from here, the diagram remains exactly the same. Delta will not change. In that condition, delta is minimum. This we have seen earlier also. So and when A is small, obviously all other things are also small, and so will be the sign of them. So instead of sine theta, we can write theta. So for small a, our mu becomes a plus delta mu by 2 divided by sine a by 2. This is equal to now if our angle A which is also called angle of prism or simply prism angle, is very small, In that case, we can write mu as A plus delta over A. Now we are not bothered whether this will be minimum or not, because when prism angle is very small, this delta itself is very small. So we can safely write this equation, in which is or if we write it in terms of delta, delta is mu A minus A, which is equal to A mu minus 1. This is when A is very small. Then we need not bother whether this delta is minimum or whatever. It need not be minimum value. So dispersive power can be written as W is equal to, this represents the maximum deviation, this represents the minimum deviation, divided by division for yellow light, which is the average of the whole spectra, and this is also equal to, in terms of mu, we can write mu for violet light minus mu of red divided by using this formula, mu of yellow minus 1. So dispersive power W is equal to, in abbreviated form, we can write like this. This is when our spectra is containing all the values from violet to red. It could be any other range also, doesn't matter. But this one should represent the average of the range we are talking about here. That's all.